Good evening all. So let us start with our discussion, limits and continuity. Right? So do we have any questions from the previous class? Any questions from the previous class? No? Okay. Fine. So here as I discussed yesterday, so if there is a function, then we will be checking if there is a limit exists for that. Now, what is this limit talks about? Suppose if I have a random function, let us say I have a function like this. On this function, suppose if I have a value randomly selected, let us say this is a, and then if I am approaching from this side, then the function value is approaching a definite value approximately at this point. So this is the function value. So this is the value of the independent variable. Now, if I am approaching from the left side, so this is what we call as the left limit. And then if we approach from the right side, in both the cases, if I am approaching the same value of the y. So here, approaching is calculated with respect to the x, which is nothing but the domain. And the resultant value is nothing but the range, or is nothing but the value of the y, or the value of the function. Now, let us say this is within a specific limit of epsilon, let us say, and then this is within a specific limit of delta, then x minus a, if it is within a limit of delta, then the function value f of x is minus f of a is within the specified limit of epsilon, then we call as the limit x tends to a, f of x reaches, this is the limit value L. So f of x reaches the value of L. And this is the fundamental definition of the limit. Here, for the x value, for a specified value of delta, so this delta is almost 0 but not 0. That means you are approaching but you have not reached that point. If that is the case, then the function value is approaching a value called the limit value. So this is the function value. So this value is approached to a limit called L. And then this range of f of x, when I am approaching this range, x minus a, so correspondingly f of x, and this value is the limit L. So the difference between these two is within a limit of almost 0. For any specified value within the limit of delta. Got it or not? Physically, if you simplify this discussion, if you are approaching from the left side, and then if you are approaching from the right side, in both the cases, if you are approaching a specified value of y, that's what we define as the limit. That is as simple as that. Got it? So in both the cases, the value has to be same. That is, limit x tends to a minus f of x is equal to limit x tends to a plus f of x is equal to the limit L. Suppose if these two are not equal, then limit doesn't exist. Got it or not? This is what is the limit. Clear? Any questions? This is a simple concept which you might have learned at +2 standard itself. So, but still we are discussing it again. Any questions? Okay, so you can note it down. I will give you a formal definition of the limit. So note down this formal definition. A function f of x is said to tend to the limit a, is said to tend to the limit a as x tends to a if corresponding to any arbitrary chosen positive number, if corresponds to any arbitrary chosen positive value positive number epsilon, however small, but not 0. There exists a positive number delta such that mod f of x minus a less than epsilon for all values of x for which zero less than mod x minus a less than delta. We write this as limit x tends to a f of x is equal to a. So this is the formal definition of limit. Got it? You can note down. Then in the same concept of limit, let us do first one limit and then we will discuss the indeterminate forms, because that forms the subset of these limits. Suppose if I have this limit x tends to a x square minus a square divided by x minus a. Now what is the limit of this? So almost everybody got it, right? So this is limit x tends to a. This can be written as x plus a into x minus a divided by x minus a, and these two will cancel out. Then you can substitute the value of a in the place of x. Then this will be a plus a. This is 2a. So this is how actually you will be finding out the limits. But by looking at the function, you might get tempted saying that this will be of 0 by 0 format. But there is a definite limit exists at the point of a. Got it or not? Got it? So this is how actually we will be finding out the limit. Now some important properties of the limits are limit x tends to a f of x plus or minus g of x is equal to limit x tends to a f of x plus or minus limit x tends to a g of x. This is how you can find it out. The limit value, you can put it separately for each and every function separately. And similarly, even the product also, x tends to a f of x into g of x can be found limit x tends to a f of x into limit x tends to a g of x. So this rule also holds good. These are the two important rules we will be using to find out the limits value. And even the logarithm case also you can use it. Limit extends to log of f of x. You can even find out log of limit extends to a f of x. This is also holds good. Got it? You can note down these formulas. Okay. So can you find out what is the limit of limit extends to 0 1 plus x whole power 1 by x. Can you find out the limit of it? I need the procedure. I think most of you might have remembered the answer. How we can do this? Okay, so this we can take it as log, then log y is equal to limit x tends to 0, then 1 by x log 1 plus x, and then you can expand limit x tends to 0, 1 by x. What is the expansion of log 1 plus x? What is the expansion of log 1 plus x? X minus x square by 2 plus x cube by 3 minus dash 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 up to infinite. This is log 1 plus x expansion. Then limit x tends to 0. If you divide with it, then 1 minus x by 2 plus x square by 3 minus dash 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 up to infinite. If you substitute the limits x is equal to 0, just a minute, I am getting a call. Yeah, sorry. Fine. Okay, so then actually once you substitute the value, this value will be 1. Then this value is nothing but log y. So if you put it the same value in the index form, y is equal to e power x. Yeah, e power 1. So this value y is nothing but limit x tends to 0, 1 plus x whole power 1 by x. This will be e power 1 or e. Got it? Okay. Then note down one more problem on these limits. Discuss the existence of the limit of the function f of x is equal to 1 if x less than 1, comma, f of x is equal to 2 minus x if 1 less than x less than 2, f of x equal to 2 if x greater than or equal to 2 at x is equal to 1 and x equal to 2. Can you people try this? Discuss the existence of the limit at the points x is equal to 1 and x is equal to 2 for the function f of x is equal to 1 if x is less than 1 and f of x is equal to 2 minus x if x is in between 1 and 2 and f of x equal to 2 if x greater than or equal to 2. Can you find it out and tell me? Exists, and what is the limit value? Okay. So at x is equal to, it doesn't exist, right? Okay. So let me analyze it. For the sake of completeness, I'll just analyze this. See this. The function, whatever is given is f of x is equal to 1 if it is x less than 1. And this is 2 minus x if it is 1 between 1 to 2. And this value is 2 if it is x greater than or equal to 2. Now here, if you want to check the limit at x is equal to 1, limit x tends to 1, f of x. Here if you want to check the limit, then here exactly at the border. So this part and this part, in both the cases there is 1 involved here. If you want to check the limit at this point, you have to check the left limit and the right limit. And the left limit is nothing but limit x tends to 1 minus f of x is nothing but limit x tends to 1 minus. So 1 minus means a little lesser than 1. Then it comes under this category. This value is coming out to be 1. So the limit value is 1 itself. And then at x is equal to 2, at the right limit, limit x tends to 1 plus f of x is nothing but you have to consider limit x tends to 1 plus, and here the function value is 2 minus x because the value comes under above the 1. So this is below the 1 left limit. Here it is above the 1. So that's why you need to consider this function 2 minus x. So this is 2 minus x. So this value, so when you are talking about x plus or 1 plus, then the way we solve the limit value, in case if you want to find out the right limit or left limit, what we do is 1 is replaced with 1 plus h and then h tending to 0. This way you can justify that on the right side of the limit h tending to 0. So limit x tends to a plus f of x can be written as limit h tends to 0 f of a plus h. This is how actually we will solve usually. H tends to 0. Got it or not? So here then it will be, so limit h tends to 0, then 2 minus 1 plus h. So h tending to 0. So this way, this value is coming out to be 1. So both left limit and right limit are equal. Hence we say that the function limit exists at x is equal to 1. So that's how we conclude that limit x tends to 1 minus f of x is equal to limit x tends to 1 plus f of x. So hence the limit exists. If it is not equal, then the limit doesn't exist. That's the only thing you need to know. Got it? Then let us check the same thing at x is equal to 2. So at x is equal to 2, that is limit x tends to 2 minus f of x can be replaced with limit h tends to 0. So f of x, so 2 minus is on the negative side of 2. So then it comes under this function, that is 2 minus, this is 2 minus h. So this value will be 0. On the right limit if you take it, so limit x tends to 2 plus f of x, and this is a constant function value. F of x is 2, then you can straight away take the 2 value. So because this is a constant value for all values of x which is greater than or equal to 2, then the left limit and right limit not equal to the right limit. Hence the limit doesn't exist. Got it? Hence the limit doesn't exist. Clear? This is for the simplicity purpose we have introduced h. So most of the times actually, if you don't introduce this h, the confusion that lies there is, suppose 2 minus, then you have to identify 1.9999 and try to place that value there in the function and try to check the value of the function there. So that's how actually you will be doing it. But in more systematic way, you can introduce 2 minus can be 2 minus h and h tending to 0. Then that is as if like 2 plus. Sorry, 2 minus. Got it or not? Anjali? This is a more systematic way of approach. Then note it down. Now let us draw the graph of this function. How it is going to be? See this. Here f of x is equal to 1 if x less than 1. That means this value is 1 till the x value is coming out to be 1. So this is the function value. Then from here to 2. So 1 to 2, what is happening is, it is having a function value of 2 minus x. So y is equal to 2 minus x is the equation. 2 minus x. Now, here, this function, if you draw at x is equal to 1, then it will start with 1. Then it will be having a negative slope there. Got it? Then, when x is equal to 2, then this value is coming out to be 2 minus 2 is coming out to be 0. It is linearly coming down like this. And then suddenly, if the value crosses this 2, suddenly it approaches 2 and then it continues from there. Just look at this diagram. See this? This is coming like this and going this way and then suddenly jumping to a function value 2. This is exactly the reason why we have the continuity at this point. And limit also exists. If the limit exists, then only we can think of the continuity. Here, there is a discontinuity. Limit doesn't exist. Because there is a sudden jump between the functions, right? So till this point it is linearly coming down. But suddenly it changed to 2 and it is maintaining a constant value there. So if you approach from the left side, this will be 0. If you approach from the right side, then it will be 2, obviously, right? So both the limits are not equal, hence the limit doesn't exist in this case. Clear? Okay. Great. So this is the basic thing that you need to understand in case of limits. These are the basic limits. Now, coming to the indeterminate forms, right? So that is also part of the limits only. So most of the times we will be arriving limit x tends to a f of x by g of x. So this is the kind of case actually most probably we will be arriving in case when we wanted to find out the limit value. Now there are some cases. One case is f of x equal to 0 but g of x not equal to 0. Then this function value is coming out to be 0, the limit value. And there are some cases wherein f of x is not equal to 0 and g of x is equal to 0. Then in such case, the limit value is coming out to be infinite. There are certain cases wherein f of x is equal to g of x is equal to 0 in both the cases. Then it is of the form 0 by 0. And this form we call as indeterminate form. Here we don't know. So 0 by 0 we cannot cancel it. So that's why we call this as an indeterminate form in mathematics. Exactly in the similar manner, if there is infinite by infinite, still actually you will not be able to conclude whether it is 1 or something else. Got it? So because this is infinite, undefined, and this is also infinite, undefined. So very large number. we don't know what is that large number. Then the result we don't know, unpredictable. That's why we call as the indeterminate form. Similarly, the other forms are infinite minus infinite is also treated as indeterminate form. And then 0 power 0 also indeterminate form. And 1 power infinity also is treated as indeterminate form. So in case of limits, actually this 1 power infinite will not be treated as 1, because 1 power any number is always equal to 1, but not in the case of limit, because when we talk about the limits, we are trying to find out the nearest value. That means if I say 1.00001 whole power, what is this value? Can somebody tell me what is this value? No? So Ross gave the correct answer. This is 1 plus x whole power 1 by x, limit x tends to 0, because the x value is 0.0001. So here this value is e. So if you calculate with the help of calculator, this is 2.71828, you will get it. This is the accurate value. Got it? So here this is one of the application of the derivatives. So one of the applications of the limits, right? Here if you notice, here 1 power infinite, the value that is approaching 1, we always treat as 0.9999 or 1.00001. But it is not equal to 1, because we are trying to find out the limit when we are approaching. That means 1 power infinite you cannot treat as 1 in case of limits. For all our practical purpose you can treat as 1, but 1 power infinite for limits purpose you cannot treat as 1, because the nearest value we are trying to count it there. Hence obviously if you multiply with infinite number of times, obviously there will be a definite value, that is going to be e. Got it? So this also you cannot treat as the normal form. All these forms we call as the indeterminate form. Got it? You can note down this. I hope everybody noted. Now, in this kind of cases, if there is an indeterminate form, then you will be using something called L'Hospital rule. What it says is limit f of x, limit x tends to a, f of x by g of x is of indeterminate format, then this value will still be equal to limit x tends to same a, but f dash of x divided by f g dash of x. So this can be treated like this. So, and then the same thing, if it is again coming out to be an indeterminate form, this will be again you can do with double derivative. So this way, till you get a finite value, you cannot keep on, so you can keep on apply the L'Hospital rule to get a finite value there. So this is what is L'Hospital rule. Suppose if it is an indeterminate format, you can apply the derivatives at the numerator separately and denominator separately, and then you can again substitute the limit x tends to a to get a finite value there. So this is L'Hospital rule. All the determinate form, all the indeterminate forms, we are going to use the L'Hospital rule only to find out the limit value. Got it? Note down some problem based on this. Limit x tends to 0 sin x by x. Can I solve this? This is straightforward. Limit x tends to 0 x minus tan x or x minus sin x by tan x. Limit x tends to 0 x square plus 2 cos x minus 2 divided by x sin cube x. Can you find out the limits of this? First one is 1, correct? Sorry, this is x minus sin x by tan cube x. Got it? Anybody? These are simple limits only, right? Yeah, that's correct. 1 by 6. See this. This one. So here actually in the denominator tan cube x is there. But we know that limit x tends to 0, tan x by x is equal to 1. So keeping this in mind, what you can do is you can divide with x cube and then multiply with x cube. Then this will be limit x tends to 0 x minus sin x divided by x cube into x by tan x whole cube. This is how you can put it. And then this value, the product of the functions, you can apply the limit separately. Now here, to apply the limit here, limit x tends to 0, x by tan x or tan x by x is again 1. So this you can replace with 1. Then what is left over is limit x tends to 0, x minus sin x divided by x cube. So you can apply L'Hospital rule on this 2 times. Then you are going to get 1 by 6. Got it? What about this one? Exactly in the similar manner. Divide with x cube and multiply with x cube. And this will become 1. And then apply L'Hospital rule on that. Again you will get the answer. Limit x tends to 0. E power x minus e power sin x divided by x minus sin x. Solve this. Got it? Yeah, 1. Note down one more. So this is one of the important model. Limit a tends to b, a power b minus b power a divided by a power a minus b power b. Solve this. 0 1 by x square minus cot square x. It should be straightforward only. I think this is a little bit confusing. Rather than that, if you convert this in this format, limit x tends to b rather than a, right? Limit x tends to b, then x power b minus b power x divided by x power x minus b power b. So this way it is convenient for you, but it conveys the same meaning. Now you will be able to solve it, right? It is exactly the same thing, but rather than taking A, I called as X because usually our convention is A and B are treated as constants and X as the variable. But here A is a variable, B is a constant. It's not log A, so it is log B. So apply L'Hospital rule on this, right? So because this is 0 by 0 format, then if you apply L'Hospital rule, so this is b into x power b minus 1 minus b power x into log b divided by limit x tends to b. Then this will be x power x, derivative will be x power x into log x plus 1, right? And this is anyway 0. And then if you put x is equal to b, then this will be b into b power b into b power b minus 1 minus b power b into log b divided by b power b into 1 plus log b. So b power b, you can take it out common and cancel it out, and then this will be 1 minus log b divided by 1 plus log b. Got it, everybody? Yeah. And this is straightforward. So apply log on this, the way we have done in the previous problem. Apply log, and then this will come here, and log of secant x divided by tan x. Apply L'Hospital rule on that. And here also you can write this as cos square by sin square, and then take an LCM and then apply the L'Hospital rule to find out the limit value. Got it? So this is how actually we will be solving the limits for any function whatever it is given. This is the most simplest topic, and the problems are actually very short in nature, but very little scope of asking the questions in UPSC. Rarely it will be asked. I don't say they won't ask, they will ask, but it's very rare. Got it? So this is about the limits. In the next class, I am going to take up continuity and differentiability. If you have any questions on limits, you can tell me now. Also tomorrow, I am going to post the daily test based on the discussion whatever we had today. Morning itself I will post. Got it? Yeah. So if you have any questions, you can ask me now. Yeah. So if no other questions, so we will stop for today, and then tomorrow we will continue the continuity and differentiability. Yeah. So thank you. Good night.